Hey guys, this video is for Calculus BC. This is lesson 10.5, and this is a continuation for polar functions. Okay, so we're going to start off talking about now the integration in polar form. When you're working with integration, a reminder that we are talking about area. If asked for the area of a polar function, then we are doing half times the integral from alpha to beta. It's like a to b, but we're going to be using degrees or radians here, of r, which remember r is the function given in terms of theta, squared, and then d theta, because again, it's in terms of theta. All right. So before looking at this first question, I want to give you a quick reminder, a little extra detail. We remember seeing these graphs in our last video. Anytime I'm working with a function of cosine, we said it either exists on the left or right. Notice that anytime we are talking about cosine, the top and the bottom are symmetrical. Okay, that's going to help us out a lot because then I could solve this from 0 to pi over 2 and then double it. Sine is either on the top or the bottom, but it's symmetric side to side, which means here I could also solve from 0 to pi over 2 and then double it to find the areas. Okay, so when I look back at this question, find the area of one petal of r equals 3 cosine of 3 theta. First, I want you to think about what this graph looks like. We know they told us petal already, but we know because there is a 3 theta here, we know it's our petals, and 3 is odd, so there are 3 petals. Because it's cosine, I know this is going to be symmetric top and bottom. If you ever need, you can always plot a few points to help you know where this is going to be on the graph. So an easy one to plot would be 0. If I plug 0 in here, we've got cosine of 0 times 3. That's going to give us 3. Okay, so I already know that on my polar function, don't mind my drawings there. I already know that there's going to point that's going to be out here on 0. It's going to be on the third ring. So that means if I have 3 petals and it's cosine, so it's symmetric top and bottom, that means one of the petals is going to reach out here. That means the other 2 must be, oops, I'm going to hit 3 over here. Okay, we can see the symmetry top and bottom based off the cosine. And because we just plotted 0, we know it's going to go out. Now, I need to know when this comes back in. Okay, so the next point of my unit circle is pi over 6, then pi over 4, then pi over 3. Let's check pi over 6. If I plug pi over 6 here, multiply by 3, do the cosine, then multiply by 3, I'm going to get 0. So I know that at pi over 6, this comes back into 0. Okay, so remember they asked me for the area of one petal. So I can do either, because now I know if this is reflecting, this is down here at negative pi over 6. I can solve my integral from negative pi over 6 to pi over 6, or I can go from 0 to pi over 6 and then just double it, because that would be me finding this top portion from 0 to pi over 6, and then doubling it would get me that bottom portion. So now that we know how we're going to set this up, okay, my area formula has a half times the integral. Now, I can put from negative pi over 6 to pi over 6 for that one petal, or I feel like it's easier to use this one because then on my f of b minus f of a, I have left a little less work or easier values to work with 0. So I'm going to say from 0 to pi over 6, but then I have to include that 2. And then of r squared, so I have 3 times cosine of 3 theta squared d theta. Okay. Now, the first thing I want to do is notice that this squared is going to belong to the 3 and to this cosine, okay? So a 3 squared is going to be a 9, which is going to be nice to take out to the front. These 2's are going to cancel. And I'm going to have, so remember, 3 squared is 9. I'm going to bring it out as a coefficient. And now I have cosine. I'm going to leave the squared on the outside. It's going to be easier for integration purposes. Okay. Now I have a little bit of a problem here. I have an inside, and an outside. So this right now is a double U sub. I don't have a formula for that. Okay. So here is where the expectation of bringing back pre-cal formulas comes into play. Okay. Your pre-cal formulas for power reducing. If I can get rid of that power, now I only have one U sub going on. Okay. So a reminder. Power reducing formula says that cosine squared of theta is equal to 1 plus cosine double the theta over 2. So I'm going to take a minute and rewrite that. Notice if I'm doubling the theta that was here, I need to double this 3 theta, so this becomes 6 theta. Okay. Now I only have one U sub going on and not 2. Life just became easier. The next thing I'm going to do, anytime I see coefficients, I'm going to take them out. So this denominator of 2, I'm going to take it out and rewrite it as 9 over 2 times the integral from 0 to pi over 6 of 1 plus cosine of 6 theta and all this d theta. All right? So antiderivative of 1 in terms of theta, that's easy. It's just going to be 1. Here, I am going to get stuck doing a U sub. All right, so antiderivative of 1 in terms of theta. Plus, I'm going to take a second and analyze my U sub here. If my U is 6 theta, then my U prime is 6. I'm going to do this a little quick. Watch me, because you can use this to save yourself time on the AP test. If I'm missing a 6, I know I would put a 6 and then a 1 over 6. I can't put the 1 over 6 up front because it does not apply to the 1. So I'm going to put it right here. And now antiderivative of cosine is sine. And then technically U sub would be of U, but my U is 6 theta. And we can do that whole U sub in one step. Now comes my f of b minus f of a. So I'm plugging this into my theta. I have pi over 6 plus 1 over 6 sine of 6 times pi over 6 minus, I'm going to put a bigger bracket, make sure that coefficient belongs to both. 0 plus 1 over 6 times sine of 6 times 0. Okay, some quick cleaning. These cancel out, and I'm doing sine of pi, which sine of pi is 0. And then this is also sine of 0, which is 0. Remember, if it's an FRQ, once you solve the trig functions, you can stop. But for the sake of this being a multiple choice, let's clean a little bit more. Pi over 6 plus 1 over 6 times 0. That's going to cancel. And then minus, we have 0 plus 1 over 6 times 0. This cancels. 0 plus 0. All of this cancels. Okay, one more bracket there to write that correctly. And now we have 9 over 2. All of this canceled, so it's just times pi over 6, We can reduce that because in multiple choice, we're almost always reduced all the way. So 3 goes into 6 twice. 3 goes into 9 3 times. And we can call this a 3 pi over 4 as my final answer. This next question says, find the area of the region between the inner and outer loops of the limosone. Okay, even if they didn't tell us it was a limosone, we see a number minus another number times the sine function. Okay, and now that this is a negative and a sine, we know it's majority on the bottom, and it's going to be symmetric left and right. I'm going to take a minute and draw that graph for you. All right, so I took a moment and drew this limosone for us. I knew that it was majority bottom and symmetric right and left because of sine. So what I wanted to figure out is up to where this closes in, because once it closes in, it changes to the inner loop. Now, why is that important? If they ask us for the area between the outer and inner loop, that means I have to find the area of the outer, which would include everything, and subtract the area of inner. And the moment where this limosone comes back into the origin, it switches to the inner loop. So I started by plotting the first quadrant. 0 was 1, and once I got to pi over 6, I saw that it came back into 0. Now, if this mirrors, then at the same pi over 6 on the left side, it would also close in, which based on my unit circle, I know that that is 5 pi over 6. Okay, so all ordered pairs down here would give me the outer loop, and all up here would give me the inner loop. Now, when I look at the image, if I go in order from the unit circle, the first part from 0 that I have is this pi over 6. Okay, so from pi over 6 to 5 pi over 6 is this inner loop. So remember, the formula does have that half integral, and we know that the inner loop goes from pi over 6 over to 5 pi over 6, and then times r squared. Okay. Now, from 5 pi over 6, right, then we have that r squared. Let's talk about this. From 5 pi over 6, the outer loop goes all the way through here. Mind you, this is 3 pi over 2. This is 2 pi, and then it goes pi over 6 more than 2 pi. Okay, so again, if we start at the unit circle at 0, the first thing we encounter is pi over 6. We start the inner loop to 5 pi over 6. Then at 5 pi over 6, we keep going, we reach 2 pi, we go pi over 6 more, and that completes the outer loop. So if I do pi over 6 plus, the 2 pi that I've reached plus the pi over 6, then when I add that together, I get 13 pi over 6. And I do that by getting common denominator and adding them together. Okay, so I'm going to do one of these at a time, find their answer, and then go ahead and subtract. All right, so I've gone ahead and I've set up the area of the outer. So step 1 is I'm going to have to FOIL this inside. And we've talked about earlier how to do the first term squared plus double the two terms being multiplied plus the second term squared. So I'm going to go ahead and do that part. We end up with 1 minus, multiply both and double them. So I have 4 sine of theta, and then plus 4 sine squared of theta. We've also seen on a previous question that I don't really want to get stuck with this squared here, okay? So what I'm going to do is I'm going to use my power reducing. This is going to turn into 4 times 1 minus 1 cosine of double theta over 2. Okay, all this is going to come right down, 1 minus 4 sine of theta. Now, if I'm going to clean this, remember this is a 1/2 minus a 1/2 cosine of 2 theta. So I'm going to distribute this 4. Half times 4 is 2. Combined with that 1 gives me a 3. And then I have this minus 4 sine of theta. And then 4 times that negative half, so I get minus 2 cosine of 2 theta. Okay, and that is what I'm doing the integral of. I'm going to bring all of this down, half times my integral from 5 pi over 6 to 13 pi over 6. Okay, now goes to doing the antiderivative in terms of theta. Here I end up with 3 theta. The antiderivative of sine is a negative cosine. Bring down the coefficient of 4, so it becomes a positive 4 cosine of theta. And then here I do have a little bit of u sub. My u is 2 theta, and my u prime is a 2. So I don't have anything missing, so I can go straight to that 2 becoming my du. Antiderivative of cosine is a negative sign. I'm sorry, a positive sign. So now this sign stays the same, and I can write this as just sine of u, and then replace my u with my 2 theta. I'm going to bring down this 1/2, and then I'm doing this from 5 pi over 6 to 13 pi over 6. I'm going to move on to do my f of b minus f of a. So I have half, and then I have 3 times 13 pi over 6, which I'm going to be able to reduce, plus 4 times cosine of 13 pi over 6. When I go to do that on the unit circle, remember that we had said 13 pi over 6 came from this spot. So the coterminal would be pi over 6. I can treat this as a pi over 6. Minus sine of 2 times 13 pi over 6. I'm going to be able to reduce that. Minus now everything with the 5 pi over 6. All right. So at this point, we're going to just start cleaning. This over here reduces. I'm going to move my paper up a little bit. So I can reduce the 3 and the 6, and I have 13 pi over 2. Cosine, remember this 13 pi over 6, I can look at my unit circle at pi over 6, and then that value multiplied by 4. I end up with 2 radical 3 minus the 2 and the 6 reduce. So I'm looking at 13 pi over 3, sine of 13 pi over 3, do the coterminal, and you end up with radical 3 over 2. Here I reduce the 3 and the 6, so I have 5 pi over 2. Cosine of 5 pi over 6 times of 4, I get a negative 2 square root of 3. And then lastly, the 2 and the 6 reduce to a 3 in the denominator. Sine of 5 pi over 3 is a negative radical 3 over 2, so it becomes positive with that negative. All right, and in this point, I'm going to start combining my like terms. Okay, I'm going to combine these two together, these two together, and these two together. Make sure you distribute that negative. I end up with half times 8 pi over 2 plus 4 radical 3 minus radical 3. And if I combine this one more time, I distribute and I combine these two. I end up with 2 pi plus 3 radical 3 over 2. So this is my answer to the area of my outer loop. Okay? So when I find this value, this is everything inside of the outer loop, including that middle loop, which is why I'm going to have to find that middle loop and subtract it. I'm going to go ahead and set that one up for you now. All right, so I've gone ahead and started writing this part. Remember, now I'm doing minus the area of inner. So I rewrote this, but I plugged in the r That was my function into this spot, right? Now, you're going to say, Ms. D, what'd you do? You already went ahead and wrote everything. Well, in this previous portion of area on the outer, we did the antiderivative of 1 minus 2 sine of theta squared. And after all of that foiling and cleaning, we came out to the antiderivative. So I will have the exact same antiderivative here, still bringing down that 1/2. The only difference is the a to b of which I'm doing that antiderivative. Okay, so you are allowed to speed up like that, okay? Make sure you're aware of what math you've already done. So at this point, I'm going to bring down my half, and I'm going to do my f of b at f of minus f of a. All right, I just plugged in my function at b minus my function at a. Now I'm going to go ahead and start to clean. The 3 and the 6 reduce, and I have 5 pi over 2. Now, cosine of 5 pi over 6, you find that value in the unit circle, times 4. And remember, let this drawing help you to know where to find it on the unit circle. Okay? So then times that 4, we end up with a negative 2 square root of 3. And then 2 and the 6 reduce, 5 pi over 3. Find the sine of that. And then times that negative, we end up with a positive square root of 3 over 2. That 3 and that 6 reduce. Cosine of pi over 6 times 4. And then the 2 and the 6 reduce. Sine of pi over 3. With that negative then involved, we have a minus square root of 3 over 2. Okay, distribute that negative and start to combine like terms. Oops, I'm so sorry. 5 pi over 2 minus pi over 2. Combine these two, make sure you distribute that negative. Combine these two, make sure you distribute that negative. Clean it a little bit more, distribute that half. We get pi minus 3 square root of 3 over 2. And this is the answer to my inner. Okay, so now remember, it's a lengthy question, but the area between is what they were asking. So we're going to find the answer of our outer minus the answer of our inner. Okay. So we have my answer from outer minus my area of inner distribute that negative, combine like terms, and my final answer is going to be pi plus 3 radical 3. So you can find it like that in a multiple choice. Remember that if this is an FRQ, you can leave it as is. And if it's a calculator section, you would have plugged in a long time ago. Okay, guys? All right, so you're probably thinking to yourself, Ms. D, you're graphing these and wasting time. I could have done a lot of that without graphing. In graphing, you're going to see details that you may not see otherwise, okay? So take a look at this. Because polar points can be represented in different ways, you're going to have to be extra cautious when finding points of intersection, right? So for example, just this point on a polar form, I can call that 1 comma pi because I'm facing pi and going 1 out. Or I can call that negative 1 comma 2 pi. It means I'm looking at 2 pi, but I take 1 step backwards. Okay, we learned that in pre-cal. So If I have the visual, I know where I can find my points. Look at what happens if I just do it algebraically, okay? Let's say I gave you these two equations and I wanted you to find where they intersect, okay? I set them equal to each other. This function equals this function. And now I work on solving theta. So I move the 1 over, I divide the -2, I do inverse cosine. Inverse cosine of 0 is pi over 2 and 3 pi over 2. So without graphing, I only get two answers, right? But if I know my graphs, I know this is a ring around 1, and this is a limosón. Negative cosine means majority left. The ratio of A to B, 1 over 2, means there's a loop. Okay, so if I draw that and I sketch a few points, I can see where the limosón lands. I know exactly where my circle lands, but I do a few points on my limosón and I can see that it intersects in 1, 2, and 3 different points. So instead of pi over 2, right, and 3 pi over 2 being the only points of intersection, I actually had a third one at 0 that went out to -1, okay? So yes, you are going to be setting it equal to each other to find those values, but the graph is going to give you that other piece of information that you might be missing. This next question reads, find the area of the common region bounded by r being -6 cosine and r being 2 minus 2 cosine. So to begin with, I know that -6 cosine of theta, negative cosine means it's a circle on the left, and that 6 is the diameter. Okay? Now, 2 minus 2 cosine, I know that's a limosón. Negative cosine is, again, majority left. And the 2's means it's a cardioid, it's a heart. Okay? I'm going to take a minute and sketch that graph. But before I do, I kind of want to figure out up to where that heart is going to go. I know with the circle I have the diameter of 6. So the furthest it'll go out to the left will tell me up to where to draw that heart. Furthest to the left would be at pi. So at pi, if I plug a pi into cosine, I get a -1 times -2 is a +2. 2 and 2 make 4. So I know I'm going to draw that heart all the way up to 4. All right, so I went ahead and I sketched both graphs, both on the same polar graph. So you can see the heart here that goes up to 4 and the circle that goes up to 6. So I can clearly see that they are intersecting once here at the origin, and once here. Now remember that polar graphs are symmetric, so if I figure out one of them, I can kind of figure out both. My job is going to be to figure out what radian this is so that I know what to integrate up into. Because points of intersection are going to be affected. Now it does this to find the area of the common region. Common region means they are both overlapping that space. So I can see that once I find that point of intersection, I'm going to have this space, right? And then I'm also going to have this space. Okay, and because they're symmetric, I can solve this for the top and double it to the bottom. Okay, so we're going to have this space, we'll call this space 1, and this is space 2. Let's go ahead and find those points of intersection. Let's set them equal to each other. So if I set both functions equal to each other, I have -6 cosine of theta equals 2 minus 2 cosine of theta. I'm going to get my cosines together, so I'm going to add these two over here. If I add 2, I end up with -4 cosine of theta equals 2. Divide the 4. So 2 divided by -4 gives me a -1/2. So now the question is, when does cosine equal -1/2? Well, that happens when theta is 2 pi over 3 and at 4 pi over 3. Okay, so if you look at your unit circle, that should match up with these two lines in the second and in the third quadrant. If you'd like to write it, you can. You have your 2 pi over 3, and here you have your 4 pi over 3, okay? All right, so don't mind my drawing, but I've taken a minute and zoomed into this graph to help you understand how we're going to do this setup, okay? We want the common areas. We've made the distinction that we have 1 as our common area and 2 is our second common area. I had to split it into 2 because I have this point of intersection, okay? So remember that area is top minus bottom. So I can split this from pi over 2 up to 2 pi over 3, right? So just this portion right here. If I just do that portion, then I only have to do the area underneath the circle from pi over 2 to 2 pi over 3, and I'll get that pink area, which is the space from number 1. So again, I'm doing the area from pi over 2 to 2 pi over 3, and only underneath the function of the circle, because I don't want to include this portion under the heart. Let's look at what the second part is going to be. If I cover this, okay, right, cover this portion right here. Now here, notice that this over here is my circle. This portion right here is just my heart. So I'm going to do the area of 2 pi over 3 to pi just underneath the heart. I don't want to include the portion under the circle. All right. All right, so I zoomed out and I wrote down what we just talked about. The first portion is going to be from, remember the formula always has a half, but from pi over 2 to 2 pi over 3, and only underneath the circle, and then the formula has a squared. We're going to add it with our second portion, which is going to be half because of the formula, the integral from that 2 pi over 3 to pi, and visually we saw it was only underneath the heart, not underneath the circle. Okay? It is important to recognize that the formula we just wrote goes only for this top portion. And we said that because it's symmetrical, we're going to solve that top portion and then double our answer. So please make sure that you make yourself some side note, whether in a big color, that you are going to, at the end, double your answer. Okay? So now, as I start to solve these integrals, the first step I'm going to take is to distribute this exponent of 2, square the -6 and the cosine, and then FOIL this over here, okay? I'm going to take a minute and write out that step. All right, so I did a little bit. Let's walk through it. The fact that I'm going to double, if I distribute that 2, notice that it will cancel out both of my 1/2, and then I don't have to worry about waiting till the end to double it, okay? Because I may forget after doing all that work. So that's why my 1/2 disappear. Then when I distribute the 2, I get 36, which is the -6 squared, and the cosine squared. Here I FOIL the first term squared minus double both multiplied plus the second term squared. Now in both sections, I have a cosine squared. We know that to do the antiderivative of that, we do not have a rule, which is why we use the power reducing formula that we've seen in a few questions already. Now, instead of putting 1 plus cosine of 2 theta over 2, I split that as 1 over 2 plus 1 over 2 cosine of 2 theta. It's going to make our lives a little easier. Okay, so if I look at this left side, I'm going to bring down my 36, okay? My antiderivative of 1/2 is going to be half theta plus, we've already seen what this u sub looks like. My u is 2 theta. Derivative of that is just 2, okay? So if I say that I'm missing a 2, it is okay as long as I put a 1/2. So I'm going to bring down this coefficient of 1/2 that I already have. We said I was missing a 2, so I need to put another 1/2. I'm going to leave that being multiplied for just a minute. And now I can say the antiderivative of cosine is a sine of u, and I'll plug my u back in of 2 theta, okay? Now, the reason I left those 1/2 is notice that if you would like, you have the option of factoring out a 1/2. You reduce this 36, and now you've got something a little simpler to work with, okay? Now, on this right side, let me move up. Before I go to do the antiderivative, I definitely have some more cleaning to do here. I have plus the integral. Okay. When I consider distributing this 4 times 1/2 is 2, and then 4 plus that 2 is going to give me 6. I can write minus the 8 cosine of theta, and then that 4 times that half is going to be plus 2 cosine of 2 theta. Now here, I have a nice antiderivative to work with. I have 6 theta. Bring down your coefficient of 8. Antiderivative of cosine is sine. And here we have the same exact u sub going on, except here I have a 2 in the front, okay? So my u sub, my u is a 2 theta. Derivative of that is just 2, but I have a 2 already, so I don't have to worry about it. This will disappear just as this one did as my du. If doing this in your head, guys, is too complicated, go ahead on the side and solve just that term with u sub on its own and take your time, okay? But antiderivative of cosine is sine of u, and my u is 2 theta. Okay, and now I can go ahead and start working on my f of b minus f of a. Here we said we were going to take out that half, is 18. And now I just have theta plus half sine of 2 theta. I'm going to take a minute and do my f of b minus f of a. This is going to be long, so it may jump down a line. All right, there's that first portion. And you know what? We're going to color code, being that we're going to see ourselves in different lines. We have this portion right here. And then I'm going to go ahead and write the next one. I'll underline it in blue. So we'll say plus. Now we're on to this one. Now I'm doing minus the bottom term. Okay, so there's the blue. All right, so my next step is going to be to clean out all of those trig functions using my unit circle, okay? I'm going to take a pause and fill those in. All right, so once we went to the unit circle, we were able to jump down to this row. All I did was clean out like the sign of this value and so on throughout my unit circle. Then I went ahead and canceled out anything that equaled 0. Within the pink and within the blue, I combined like terms, okay? And then I saw I was working with terms with pi's and terms with radicals. So for my radicals, I got common denominator 4. I have a negative 18 here and a positive 16 and 2, which make 18. So those cancel out. And then I'm left with a 3 pi plus a 2 pi with a final answer of 5 pi. All right, next up we are looking at arc length in polar form. Here we have our formula, which is the integral from alpha to beta of the square root of r squared plus r prime squared, and with respect to theta. So a reminder that r is the function, so they can write r or they could put f of theta. Either way, they mean the same thing, okay? And then you're going to just solve the derivative, plug them in there, square them, and start cleaning it out as best you can to then just hopefully do a simple integral. This first question says find the arc length of r, which is 2 minus 2 cosine, from 0 to 2 pi. If they weren't nice enough to tell you from 0 to 2 pi, I know that 2 minus 2 cosine, a number minus a number with a trig function, is a limosón. A 2 and a 2 means the ratio is a 1, so it's a heart. And the negative cosine means it is majority left. So even if they didn't give me that 0 to 2 pi, I know that this graph takes up all 4 quadrants, so I would have to do from 0 to 2 pi, okay? So now I know for my formula, I'm going to need r, but I'm also going to need r prime. Derivative of 2 is 0. Bring down the coefficient of a negative 2. And derivative of cosine is a negative sign. So we have that r prime is a positive 2 sine of theta. Now I'm ready to plug in my r and my r prime. So I can say arc length is the integral from 0 to 2 pi. And then I'm going to go square root of r, 2 minus 2 cosine of theta, squared, plus r prime, which is 2 sine of theta squared d theta. I've got a little cleaning to do here. We've talked a lot already about how to FOIL this quickly. We have the first term squared, and then double both of them multiplied together. So 2 and 2 make 4, double it, it's 8. So we have a negative 8 cosine of theta. And then the last term squared. So a negative 2 cosine squared would be a positive 4 cosine squared. And now plus this squared belongs to the 2 and to the sine. So I have plus 4 sine squared of theta. All this lands in the radical. We still have not integrated. I've got to keep writing that. So now the fact that I see a cosine squared and a sine squared together make me think of Pythagorean. I do have that 4 in the way. So I can say I'm going to factor out the 4 and put cosine squared plus sine squared. So cosine squared plus sine squared equals 1. 1 times 4 is just 4. So then I can add it over here with this one and say 4 plus this other 4 is going to be 8 minus 8 cosine of theta d theta. I can factor out my 8s. I'm going to bring that square root of 8 out to the front. All right, now the inside of this, I do not have an integration rule for this, okay? It would be technically a u sub because I have an inside and then the square root is the outside. But I do have some tricks from pre-cal that I can use, okay? If I think of which one of my pre-cal formulas from chapter 5, this 1 minus cosine looks like, I know that I have a formula that states 1 minus cosine of theta, but over 2 would equal sine squared. And if I can rearrange that, that'd be nice because then the sine squared would cancel with the radical. So if I want to, I'm sorry, a 2 theta. There is a 2 in there, which I will be able to get rid of, okay? So if I can isolate a 1 minus cosine theta, I can replace it. Let's multiply that 2 to the other side. 2 sine, and I'm going to go ahead and put the squared on the outside already, equals 1 minus cosine of 2 theta, okay? So that means this equation here is true if the theta that I put over here is double the one I put here. So if I put 45 into theta, I'd be doing sine of 45, and then I'd be doing cosine of double that, which is 90. So I can also say the reverse, that this theta has to be half of what this theta is, right? I can rewrite that as 2 sine half of that theta. And then here write 1 minus cosine of theta. So again, if this statement is true and this one has to be double this one, I could say the same thing, that this one just has to be half of this one. And now that I've isolated 1 minus cosine, I can replace that in here. And I can say I have 2 times sine of theta over 2, and then all this is squared. So the nice thing about this is that I can separate this, right? I'm going to separate with multiplication right here. So I'm going to take that square root of 2 out over here, and then the square root is going to cancel with this square. So 2 times 8 is 16, right? So I'm going to write square root of 16, even though I know we can clean that to a 4. 0 to 2 pi. And then here, I'm just left with sine of, instead of theta over 2, I'm going to put half theta. And now I have a very simple u sub. Again, that square canceled out with that square root. That's why we don't see it anymore. So now I can say, all right, if my u is going to be half theta, then my u prime is going to be half. I'm missing that half, so I'm going to put it in, as long as I put a 2 on the outside. Now I do need to change my a to b, so I'm going to say u at 2 pi is going to be half of theta, which is half of 2 pi. So I'm going to use pi as my top limit. And then u at 0, which is half of 0, which is still 0. So now, square root of 16 is 4. Times 2 is 8. So I have 8 times the integral, my new limits, from 0 to pi, of this half. Remember, it disappears into my du, and now of just sine of u. Antiderivative of sine is going to be a negative cosine. And now I'm just doing my f of b minus f of a. So I'm going to take the negative to the outside with the 8. I'm going to say negative 8, and then cosine of pi minus cosine of 0. Now cosine is the x value, so I have negative 8. Cosine of pi is a negative 1 minus cosine of pi is a Oh, I put a theta. Look at me. That's supposed to be a 0. I'm sorry. Cosine of 0 is a positive 1. So negative 1 and negative 1 make negative 2. Negative 8 times negative 2 gives me a positive 16. So it's 16 units is the arc length of that function. All right, our last topic for this section is the area of a surface of revolution. So think of a 3D object that's starting to revolve, like we had learned earlier on with, area revolving. And now we're going to find the surface area of that. Okay, so it depends on what we're revolving around. Remember that the polar axis is like the x-axis, and then pi over 2 is like the y-axis. So be careful not to get it confused with my previous video before we're talking BC with rolling and white growth. This is different, okay? So if we're revolving around the polar axis, we have 2 pi times the integral from alpha to theta. All this is the same, right? And then times r, which is a function they give you. If it's around the polar axis, you have to multiply a sign in there. If it's around pi over 2, then you have to multiply cosine in there, and then the rest is the same. The square root of the function squared plus the derivative of the function squared, all with respect to theta. All right, let's go ahead and look at this example. Find the surface area formed by revolving cosine of theta about the line pi over 2. So because it's pi over 2, I'm going to be using this formula, okay? So if r, let's make a little side note here, if r is cosine of theta, then r prime is going to be a negative sine of theta. So I already know what I'm plugging into these two spots and this one over here. Now, cosine of theta, the actual graph, I know that it is a circle only on this right side, okay? So I can do this from negative pi over 2 to positive pi over 2, or I can go from 0 to pi over 2 and then double it, okay? So it'll just be finding this amount, and then I double it to get the bottom as well, okay? So let's go ahead and do that. I'm going to say my surface area is 2 times, so remember I'm doubling it. Now I'm going to go ahead and put my formula, 2 pi times the integral. We said from 0 to pi over 2 times r, the function. R is cosine. Because it's about pi over 2, I'm going to multiply it by cosine. And then square root of r squared, which in this case is cosine squared, plus r prime, which is a negative sine of theta, squared, all that's the inside of the square root, and then d theta. Okay? Now it is time to clean. The 2 and the 2 are going to make 4 pi. Cosine and cosine make cosine squared of theta. Here I have cosine squared plus the negative is going to disappear and it's going to be a positive sine squared, which is really nice because I know that cosine squared and sine squared equal 1, and square root of 1 is just 1. And 1 multiplied to cosine squared is just going to be cosine squared. So this cleans up real nice. I have 4 pi times the integral from 0 to pi over 2. I'm going to write this as cosine of theta squared. And then remember, times 1, it just stays the same. And of course, in terms of theta. Now, I do not have an integration rule for cosine squared. I cannot do u sub because what I'd be missing would be a whole trig function. But we've seen it several times already in this lesson that I do know from pre-cal that cosine squared of theta is equal to 1 plus cosine of theta over 2. Okay? Sorry, the paper was a little shifted, and it was 1 plus cosine of 2 theta over 2. So I'm going to rewrite that because now here I do have an easy antiderivative. I'm going to rewrite that as half plus half cosine of 2 theta. Okay, antiderivative of half is going to be easy. Here I have a little bit of a u sub going on, okay? So be careful with that. If my u is 2 theta, then my u prime is going to be 2. If I'm missing that 2, I need to put it, but in addition, also put a 1/2, okay? An additional 1/2 other than that one, because that one was already there. So I'm going to be putting in a 2 times a 1/2, okay? Know that this 2 is going to disappear as my du, right? So I'm not going to go through the whole motions of writing the du. You could, if you'd like to, just solve it on the side. But when I go to do my antiderivative, I'm going to have 4 pi. Antiderivative of half is going to be half theta. Plus, we said the 2 disappears with the du. And then I'm going to be left with this half and this half, which make 1/4. Antiderivative of cosine is a sine. And then I plug my u back in of 2 theta. Remember, if I plug my u back in, I do not have to change my limits of a to b. You can factor out a half here if you'd like. It'll cut this to a 2 pi. And then it'll be a theta plus half sine of 2 theta, if that makes you happier, just to work with smaller numbers. Remember that zeros do not automatically disappear in f of b minus f of a when there's a trig function. So I have 2 pi, my function at b, minus my function at a. So here, the 2's cancel, and I'm working with sine of pi, which sine of pi is 0, which will cancel out this entire term. I have a 0 here, and then 2 times 0 is 0. Sine of 0 is 0, canceling out this entire term as well. So I end up having 2 pi times, I have pi over 2 plus 0 minus 0 plus 0. I just end up with pi over 2, which gives me a final answer. These 2's cancel out, and I'm multiplying pi times pi, which gives me pi squared.